Hello, statisticians. Today we are learning about bias and non-random sampling. Let's get started. To help attract applicants, colleges spend a lot of money renovating and maintaining their pretty campuses, sending out pretty mailers to prospective students, and showing off their pretty data. Yes, that's right. Colleges go to great lengths to share data on their generous financial aid awards, impressive graduate salaries, high job placement rates, and stellar campus life satisfaction survey results, all of which can show prospective students how happy they'd be if they attended their university. But that also raises the question, does this data always paint the most accurate portrait of life on campus? So that brings us to our key question for today. Can data about colleges be misleading? With that question in mind, let's move into our notes. We're going to cover 3 topics today, starting with bias. You may know about bias as supporting or opposing something or someone in an unfair way because of personal opinions. In statistics, bias is a flaw in a sampling method or measurement procedure that leads to systematically overestimating or underestimating a parameter value. It's important to pay attention to bias because it can lead to unreliable or wrong conclusions. The key to eliminating bias is to sample randomly from the whole population of interest. To dive a bit more into what bias is and how to avoid it, we are going to describe several types of statistical bias, starting with sampling bias. Sampling bias is bias that comes from selecting a sample that is not representative of the population of interest. It might happen out of convenience, or to keep costs down, or for any number of reasons. We'll look at 3 types of sampling bias as we go through this course. The first is selection bias. To explore selection bias, let's take a look at some pretty data from Palo Alto College, a community college in San Antonio, Texas. According to the school's website, in 2021, 89.3% of their graduates found full-time work or enrolled in their next level of schooling. Keep in mind, this is a community college, so both of these outcomes, finding work or transferring to a 4-year college, can both be considered good outcomes after graduation. Imagine that a friend of yours, after reading this, says, "That's great, I'm going to apply." However, this 89.3% statistic might actually be misleading. Take a moment to pause and think about how this statement might be misleading. Okay, let's discuss. So, note that the statement says that 89.3% of graduates had good outcomes. Not 89% of all students who enrolled at the school, but 89% of graduates. That raises the question, how many students actually graduated? Well, by law, graduation rate data is reported to the government and is publicly accessible online. And if you look it up, it turns out that among students who enrolled in Palo Alto College in 2020, only 48% either graduated or transferred out. So, although many of these students had good outcomes, among the other 52% who didn't graduate, we don't really know what happened to them. So ultimately, the majority of the students who enrolled in the first place, 52%, did not graduate. These students may have had a tougher time finding jobs. So what does this say about that pretty 89.3% statistic we saw earlier? It's BS, and we know what that means. Bad statistics, of course. This is an example of selection bias, when part of the population is excluded or less likely to be selected for a sample. In this case, non-graduates were excluded from calculations of job placement rates. So, if you want to describe a potential flaw in a sampling design like this one, you'll want to make sure to cover a few things. We can start with the broad and then zoom in, much like we have done before. First, identify the population of interest, and then the sample, then zoom in to identify the observational units that may be excluded from the sample and how they might differ from those that are included in the sample, and explain how the exclusion could lead to an over or under estimate. So, taking the example from earlier, if you wanted to explain to your friend about what might make this statement misleading, you'd first want to name the population and say that it was all students who enrolled in the college. Next, you'll want your friend to know that the sample was just the students who graduated. Then you'd want to explain that non-graduates were excluded and they might have struggled to find jobs, and the statistic likely overestimates the true job placement rate. So you could tell your friend, prospective students like you may be interested in the job placement rate of all Palo Alto College students, but the sample only includes graduates. This excludes non-graduates who may have had a harder time finding jobs. So the 89.3% is likely an overestimate of the true job placement rating among all students. Now, it's worth noting that even if you really just are interested in job placement among just the graduates, these sorts of figures can still sometimes be misleading. And that's because of another type of sampling bias, non-response bias. To see non-response bias in action, we'll look at another set of college data, this time from Rogers University in Oklahoma. In a report studying graduates from 2017 to 2019, Rogers State found that about 75% of their graduates were pursuing another degree or had found full-time employment by their final semester. Again, it looks pretty impressive at first glance, but what if we ask, how did the university collect this data? Well, it turns out they used surveys. And the sample report shows that the response rate of the university survey was 20%. So only 1 out of 5 graduates responded. This low response rate is another warning sign of, you guessed it, bad statistics. And that's due to a sampling bias called non-response bias. Non-response bias happens when individuals who do not respond to surveys substantially differ from responders. For example, non-responders on alumni surveys may differ substantially from responders, especially when it comes to questions about finding jobs. To explain, we'll use the same process we used before. If we are asked to identify a potential flaw in the university sampling method, we'll first identify the population of interest, in this case, all alumni or all graduates. Then we'll identify the sample that was actually measured, which in this case is all the alumni that actually responded to the survey. Then we'll discuss who was excluded. This sample excludes non-responders, some of whom may have been without a job and may have been embarrassed to respond to a survey about their job status, suggesting that the survey overestimates the true job placement rate. That means that you can argue that the 75% is likely an overestimate of the true job placement rate among all graduates, as our sample excludes a part of the population that may be more likely to be unemployed. The final type of sampling bias that we'll talk about is voluntary response bias. Voluntary response bias occurs when a sample consists of entirely volunteers who may differ from the general population. Imagine that we're looking at a case like this. A university official believes that students at their school, which provides free gym access, have especially good cardiovascular health. To test this idea, the official recruits student volunteers to run a mile and then measure their average heart rate. They're being asked to describe a potential flaw in this sampling process. Go through the parts of creating an argument as I read this statement, describing a potential flaw in this study: population, sample, and exclusion with results. The official is interested in the average rate among all students at the university. However, the sample only includes students who volunteer to run a mile. This excludes students who don't volunteer, who may have a higher heart rate than those that choose to do the running. So the official may underestimate the true average heart rate among all college students. Now, on to response bias. Response bias is a category of bias that arises from responses to a survey being different from true values. And when we're giving a survey, even if the sample is well chosen with no sampling bias, you may still run into response bias. For our purposes in this course, we're looking at two types of potential response bias. The first of those is the way the question is worded. Question wording bias happens when survey questions are confusing or leading. For example, if the survey question was, which show would you prefer? Diners, Dive-Ins, or Dives, hosted by the incredible, talented, funny mayor of Flavortown, Guy Fieri, or Iron Chef, hosted by the boring Alton Brown. You can see how that question may lead to an overestimate of support for Diners, Dive-Ins, and Dives, or an underestimate for Iron Chef. The other type of response bias is self-reporting bias, which happens when individuals inaccurately report their own traits. For example, if I was asked on a survey how much weight I could lift for bench press, I might respond that I can bench 150 pounds. But honestly, maybe I'm embarrassed that I can only actually lift the bar, about 45 pounds. So I overestimate on the survey. And that's actually a common threat of many self-reporting surveys. People will alter their responses to make themselves look better. So, to summarize, one way that bias can arise is from issues with how the sample is selected. This category is called sampling bias, and there are three subtypes, each of which we've talked about. Bias can also arise from how the data is measured, especially when it comes to surveys. This category is called response bias, and we've talked about two subtypes. You'll want to remember that in other places and spaces, the names given to bias may change, but what's most important is how it arises and its impact. So that brings us to our discussion question for today. Imagine that a university official wants to gather student opinions about campus housing. It's a big campus, so sampling across campus is time-consuming. Given limited resources, they have two options. They can either survey a random sample of 25 students from across campus, or survey 500 students from one dorm. Our discussion question is, which option should the official choose and why? Take a moment to jot down your initial thoughts, and then you'll be ready to share this idea with the class. That's it for today, statisticians. We'll see you next time.